This recording is to help you with lesson 3.04, solving exponential and logarithmic equations. Alright, let's start out by approximating the point of intersection for f of x and g of x. So that is where they will equal each other or cross each other. So let's set 2 to the x power equal to 8. Using our properties, if I can get the same base 2, I know that I can set my exponents equal to each other. So let's rewrite 8 as 2 to the third power. And now that they both have base 2, I can just say that x equals 3. Therefore, the point of intersection will be x equaling 3 and when y is 8. For the second one, let's change that from logarithmic form to exponential form. That would be 4 to the third power equals x. And 4 cubed, which is 4 times 4 times 4, is 64. So the next one, let's change this to exponential form as well. Remember, natural log has base e. So we can say e to the 0 equals 2x minus 1. And anything to the 0 power is 1. If I add 1 to both sides, I get 2 equals 2x. Divide both sides by 2, I get x equaling 1. Another way you could have done it is you could have said, well, let's take e to the both sides. We know e and natural log are inverses of each other, so you're left with 2x minus 1 equals e to the 0, and that's where we picked up over here. So that's another way that you could have gotten there. I just said that e and natural log are inverses of each other. So to simplify that, we are left with just x squared for our answer. For the next one, I want to try and isolate the e to the x power. So I'm going to start by subtracting 7 from both sides. When I subtract 7 from both sides, I get negative 2 times e to the x power equals negative 2. Let's divide both sides by negative 2 to get e to the x equals 1. And now to get rid of e, you would take natural log of both sides. So natural log and e are now gone. You're left with just x equals natural log of 1. And this is also a property that the natural log of 1 equals 0. What you could have also realized is that the only way you can get something with an exponent to equal 1 is if your exponent is 0. So you could have also jumped to the conclusion that x must be 0 using that property as well. All right, it looks like we all have log base 10 of everything here, but we need to combine the left-hand side before the log base 10 can drop away. So to combine something that you are subtracting, you use division. So we have log base 10 of x plus 4 divided by x equals log base 10 of x plus 2. Now your log base 10s are on both sides. They can drop out. So you're left with x plus 4 divided by x equals x plus 2. Let's cross multiply here. So x times x plus 2 is x squared plus 2x. And multiply in the other direction, we just get x plus 4. Let's move everything to one side by subtracting x and subtracting 4. And that's how you get 0 equals x squared plus x minus 4. From that point, in order to solve for x, you could try factoring, or you could try the quadratic formula. Factoring does not work in this case, so you have to use the quadratic formula. When you use the quadratic formula, you get this response here. Now, only the positive value makes sense to use. We do not want to include the negative value because negative values are not in the domain for logarithmic functions. So we only want to state the positive answer. And this is the same process as the last one. We need to combine what's on the left-hand side. This time we're adding. So in order to combine that, we need to multiply. So that's how we can get that written right there. Notice that they are both log base 3, so now the log base 3's can drop out. Let's distribute the x on the left-hand side to get x cubed minus 8x. Let's subtract 8x from both sides so that everything is on one spot, or on one side. And then let's work on factoring. I can pull out an x and have x squared minus 16 left. And that factors to x plus 4, x minus 4. So setting each part equal to 0, I now get x equals 0, negative 4, and positive 4. The only solution that works, though, is x equals positive 4. Because remember, your domain for logarithmic functions has to be x greater than 0. So greater than 0 does not include 0. So 0 doesn't work and negative values don't work. So therefore, the only solution is x equals 4 in this problem.